Hey guys, what's up? Welcome back to the shop once again. It's another hot one today in Chicago, but we must truck on and diagnose the braking system on this 2009 Ford Escape Hybrid. Now, the reason why the braking system is so much more complex than a hybrid is because the engine is not always on to provide that vacuum assist to the booster. So they must add additional pressure and vacuum sensors, active boosters, brake feel simulators, and of course on the 09 and newer, they have brake vacuum pumps so they can provide vacuum when the engine is off, whereas 2005 to 2008, it was a much more complex system where they had an actual hydraulic motor assembly to provide that pressure assist at all times. So on this car, I pulled codes already. We'll show you the codes here in a second. We have a C1015, which basically means the vacuum is not always there when the engine is off. So there's something going on with the vacuum pump that provides the vacuum assist when the engine's off and it's in hybrid mode. So we need to go after that. So let's go over to the scan tool and check it out. All right, here we go. Now, the very first thing I want to mention is that this diagnostic video applies to the 2009 through 2012 Ford Escape hybrids. They use the vacuum pump, the electric vacuum pump, to provide assist when the engine is off to the booster. Whereas 05 to 08 used a much more complex hydraulic control unit, one that had the electric motor on there, the accumulator, all that good stuff, you know, one that cost $5,000. Well, they got rid of that in 09 and they went to a much more basic system, still using vacuum at all times, okay? Whether the engine's on or off, just comes from a different source, okay? So this one right here, yeah, as you can see, yes, it has 350,000 miles almost on it. It was a taxi before this customer got a hold of it, so it has the original engine and trans. Just goes to show these things do last. Just a couple things around it fail over time, as you can imagine. So let's go over here and we'll pull codes on it. Now, any scan tool can pull codes on the ABS module. It runs off the high-speed CAN network, so they'll be able to talk to it and pull codes and see what is going on here. So the codes we're looking for, I mean, we're just going to pull all the codes from it. Battery voltage, very basic code, 1014. It's having problems with the total volume balance, basically the pedal travel sensor. Well, that is all related back to the vacuum not being there at all times. Then we have more specific codes for the vacuum supply not being there, okay? I mean, basically this means signal plausibility failure. Basically means it turned the vacuum pump on, everything looked good to go. Okay, the relay clicked on, but there was no change in the vacuum supply with the sensor, so what's going on? So it's kind of like freaking out. And it has another code, same code, but it has a subcode of 7B, which is low fluid level, okay? Believe me, it has nothing to do with the fluid level in the master cylinder, okay? I mean, look at this right here. It's very confusing for a lot of you out there that aren't used to working on these. Where's it at? 7B, low fluid level. This DTC will set an ABS module if it detects a vacuum leak, a vacuum fittings, vacuum pumps, pressure sensors, booster, vacuum, everything vacuum. It's nothing to do with fluid, okay? This goes to show some of these codes can be misleading. Okay, so we'll go down. Again, regenerative braking disabled because anytime there's a fault in the system, it goes into a like a failure mode where it goes into a very basic failure management effects mode, they call it. So it can just get you down the road into the repair shop, okay? So all the extracurricular activities kind of stop and it goes back to the basics. Steering angle sensor, again, does not have anything to do with us. It's obviously an issue, but it's nothing to do with our vacuum pump. And then I pull codes from all the modules, and this is why. So we're going to go down to the PCM here, and we're going to look at the codes in here. Look at this code right here. These are all bits and pieces that kind of they're all pieces of the puzzle they put together to kind of figure out what's going on here. So this, again, this is the ABS module asking the PCM to run the engine at all times, even in hybrid mode, because there is no vacuum supply coming from that booster, or that vacuum pump, to the booster, so it's relying back on the engine vacuum supply, and it needs to be running to provide that, okay? So it's requesting that the engine be on at all times, forced engine running at all times. Okay, so we know there's a vacuum supply issue. Let's go over to some live data on the ABS module, and these are the PIDs you want to pull up on there. So we're going to check the vacuum pump, see if it's coming on or not. On my scan tool, it's bidirectional, so I can turn it on at will. And then we're going to look at the pressure sensors, okay? There's two of them on the brake booster here, okay? and we can kind of check on to make sure they're actually working by monitoring them. So they're redundant, so that it makes sure that it's getting an active and good quality signal. Okay, so right here, bringing up information on here, the very first thing you want to do is look at these two sensors. They should read the same, very, very close to the same, okay? And they do, okay? Now the next thing you want to do is check to make sure they're not biased, okay? What we're going to do is we're going to come over here to this line right here that goes over and just sticks into a rubber grommet on the booster. We're going to pull it. You're going to hear shh. That's all the vacuum releasing from the system, and then these at the same time in live, live data stream here, will go down to 0 psi. Okay, so right now you can see it's in a vacuum. I'm gonna come over here. We're gonna yank on it. I'm gonna try to get you to look at this while I'm pulling on it. Oh, and you can see right there, they dropped off, and they're both reading right at 0. You can see they dropped off. So they're both responding and they're good to go, okay? Next thing we're gonna do is we're gonna concentrate on that vacuum pump itself. Now for me, and if you have a bidirectional scan tool, at this point, we can find the cursor, come over to it, and we can literally turn it on. It allows bidirectional control of the vacuum pump. So what I'll do is I'll turn it on. Okay, you can see it's on right there. And then in this case, I should be able to come over here and just stick my hand on the end of it, and I'll feel vacuum for the time the vacuum pump is on, okay? And you'll hear it going down there also. This one is not responding at all. So let's go down below, and we're gonna do some diagnostics. All right, here we go. We're gonna slide underneath the vehicle. No need to jack it up at all. Right here in the very center, you can see the shields are still in place. No need to remove them. We're gonna come underneath here. We're gonna look up above the oil filter at the vacuum pump itself. You can see a big monstrosity of aluminum right there. That's the brake vacuum pump. Now what's really nice about that is that it's right here to change out, but also the electrical connector is right here to test. So we're gonna do some basic tests on the voltage and amperage coming into it to make sure it works, and we can do it all from right here. So it's very, very easy. Now that noise you may be hearing is the max pump right here. That has nothing to do with our brake vacuum pump, and our brake vacuum pump should be much louder than that, okay? So don't mistake the two. So what we're gonna do is we're gonna disconnect this, okay? As you depress the tab right here, we're gonna separate this, and we're gonna do some tests on the voltage and amperage coming into it from the harness side. This is the body side right here. And one of the first things I noticed on this one is this kind of just like sitting here, dangling, and it rubbed right through the backside here on the edge of the oil pan in the block here. So that's something to check on there for chafe points to make sure it's okay. And what we're gonna do is with my scan tool, I'm going to turn it on with the module, okay? And it's gonna send voltage down the connector, and then we're going to test it with a window motor like this, pull some good amps on there, and we can really test that circuit to make sure it can handle and work this vacuum pump, okay? It's very important to load test your circuits. So we're gonna go ahead and connect that up and start testing. All right, and that looks a little something like this. Now it doesn't matter which one you hook up to because we're testing both power and ground coming into the actual vacuum motor. But just for reference, the black one is the ground, and the white with the stripe on there is the power coming in that switched from the ABS module relay. The ground, of course, is constant. So here we go. We're gonna watch this to make sure it can spin the motor and handle all that amperage in that circuit. So we're gonna go ahead and turn it on. Let's see. All right, here we go. Turn it on. There it goes. Runs it, no problem. And this one times out because it doesn't want the pump running constantly for obvious reasons. But anytime I turn it on via the ABS module, it jumps and it runs just fine. So it has plenty of amperage to run that vacuum motor. So right there, that's a really quick, simple way to test and make sure the ABS module works, ABS vacuum pump relay works, and of course this wiring all the way down can supply what it needs to make that vacuum pump work. Now at this point, the vacuum pump should just come on and start going until it gets commanded off by the ABS module. This one is not doing that. So with that tested, the very next thing we're going to do, because we know this is good to go coming in, for the heck of it, just to make sure, because it is a $500 part, we're going to apply vacuum or power from an external source to those 2 terminals on there, and that pump should come on. Okay, you hear it running. For this next test, we're going to use an external battery source. I'm using a jump pack, or you can use the low voltage battery under the hood, some 14 gauge jumper leads, and I'm going to run power directly to the connector of the vacuum pump itself. So the right hand side there is the positive, so I have it going into there and staying constant, and we'll put the ground to it and switch it on the other side there. Now you should hear the pump come on, and you should see a good amount of sparks also, because it is a good amount of amperage it's using. Kind of getting up in there. I do see some sparks, so our connection's definitely, our circuit's complete, but that pump is not coming out at all, it's dead. Now what I think is going on here, and what's pretty common on a lot of these, is that aluminum housing, they like to ingress water inside of there and just corrodes big time in there. The pump seizes, or the electrical motor in there actually comes apart from the corrosion, and it's done for at that point. Now the Ford EcoBoost F-150s use the same thing at first, an aluminum pump, because it's quieter, but it takes in that water and it just rots the whole darn thing out the whole time you're driving. So the new ones are all plastic inside and out, okay? And that's how it is on this one. So that's what's probably going on this one, but if it's original and 350,000 miles, it's okay at this point to fail. Now on this one, it's pretty cut and dry. We turned on the vacuum pump with the scan tool. We saw power come down to there. We load tested, everything's good to go. Didn't work still, and then we also provided power directly to that vacuum pump. Still not coming on. It's pretty obvious after 350,000 miles, it's done for, okay? We need a new vacuum pump, and we're just gonna go from there. It's pretty obvious. Now you're probably wondering, what if I don't have a fancy scan tool like this where I can just turn it on and off bidirectionally at will? Well, what you can do is you want to go in and you're going to clear all the codes, then you're going to turn the key off. Then you're going to start the vehicle up, let it run enough to satisfy the battery charge in the back till it goes into that hybrid mode, where it turns the engine off and you're just in that electric mode. At that point, it knows there's enough vacuum in the booster, there's enough charge in the battery, and it's relying on all these extra components on here for the hybrid operation, okay, the electric operation part of the hybrid system, okay. Now it's really watching those 2 sensors to make sure there's plenty of vacuum in there, and it's going to command on that vacuum pump whenever it drops to a certain level. So you simply pull that hose while it's sitting here in hybrid mode, okay, in electric mode, and it's going to drop that vacuum in there. And what that's going to do is that's going to turn on that vacuum pump down below. So make sure you have your test leads attached to it and ready to go to load test it, and then you'll be able to see if the ABS module recognized it via the sensors working properly, okay, and if it also was able to turn on that relay and send power down, sufficient power and amperage to that vacuum motor. So you're basically tricking the system into thinking it doesn't have enough vacuum, so it's in hybrid mode, it's going to turn that vacuum pump on, okay, electrically. And you can test it that way. The next thing we're going to do, of course you want to do on any of these systems, is check your vacuum lines. So you want your vacuum lines coming up and out of here, going down over to the pump, make sure there's no splits, tears, anything like that, going all the way over, okay? And then we're also going to check this check valve. There's 2 check valves built into this T here. It's not a regular T. So we're going to take that off the vehicle, we're going to bench test it to make sure these check valves are working properly. Because if this one fails, and the vacuum pump comes on in hybrid mode, and it's just sucking atmospheric air over here, that's the same thing as a vacuum leak. Same exact thing. And it's going to think the vacuum pump's not working properly, when in all reality it is. It's just bleeding off to here and never getting over to the booster. So we're going to check this to make sure we're checking the full system before we just condemn the pump and say that's it, and that's the only problem. So let's pull it off. It just twists right off. We can go over to the bench and test it. Now, because this code can also come from vacuum leaks or vacuum check valve failures, we're going to check this dual check valve T that's part of the system on here. So this side goes to the booster, and then these are your 2 sources of vacuum, okay? So the very first thing I'm going to do is I'm just going to take my vacuum pump, and we're going to stick it in this end right here that goes over to the booster itself, and we're going to pull a vacuum on there. So we're going to pump, pump, pump. We're going to pull a vacuum and make sure it holds. That right there is checking both of these check valves in here to make sure they're working properly. Now, let's simulate, for the heck of it, let's put a cap on this end right here. It goes to the booster, because the booster is a sealed system, okay? So we'll do that, and then the next thing we're going to do is we're going to connect it to the engine side right here, okay? And we're going to pull a vacuum on that. So we should be able to pull a vacuum. It'll pull a check valve and it'll allow vacuum into this chamber. We're capping it off right here, of course, and this one should cap off this outlet right here. So we're going to check both of these again in a different way. Pull vacuum, look at that, it holds, okay? So that means when the engine's running and supplying vacuum over to the booster, the other check valve right here is keeping it closed so that it's not bleeding off down to the vacuum pump, okay? So now we're gonna do the same exact thing. We're gonna pretend we're the vacuum pump pulling a vacuum right here, feeding the booster, and the engine's off. So right now this is gonna be open to atmosphere, so we need to block that off with the check valve. So we're gonna make sure this check valve works. Same thing. Gotta stop touching that release down there. There you go. Sits there and holds all day long. So we know that our check valve on here is good to go, and that's good because this check valve and T-system and those hoses is about $85 might cost. That's a lot of money just for some hoses and a check valve. But it checks out, so we know the vacuum pump is our only concern at this point. We need to replace that and retest. It's very, very simple. As long as you follow these diagnostics, you can figure it out real quick and have a definitive answer. That's all for now. Hope I helped you guys fix your Ford Escape Hybrid yourself. I'll see you next time, guys.